Dear students, welcome to today's class. Today I am going to explain some problems from the chapter set theory which are very useful for our preparation of JEE mains examination. The first problem is set A has m elements and set B has n elements. If the total number of subsets of A is 112 more than the total number of subsets of B, then the value of Mn is. See here, the question is a very clear. But it was asked in 2020 mains examinations. Let us see here. Set A has m elements, set B has n elements. Clear? So the problem is regarding subsets. How many, if a set A has m elements, how many subsets it will have? Number of subsets is equal to 2 power m. Set B has how many subsets? That is, we have the formula 2 power n. Clear? So he is saying the total number of subsets of A, that is 2 power m, is 112 more than the total number of subsets of B. That means 2 power m is nothing but 2 power n plus 112. That is the thing. So if it is clear, 2 power m minus 2 power n is equal to 112. This is the equation number 1. Now he is asked to find out the value of Mn, m into n. That means you have to find out the value of m and n, but unfortunately you got only one equation. As you know that, so if you want to find out two values, you require two equations, two variables, two equations, but you got only one equation. So is there any more information is given? Nothing is given. Understand? Then how to solve this? How to solve this equation is, first what I want to do is just take the 2 power n common outside. So if you take 2 power n common outside, what happens here? So this is equal to 2 to the power of m minus n minus 1 is equal to 112. Understand? 2 power n into 2 to the power of m minus 1 is equal to 112. So if you observe this, now this is even number clearly and it is odd number. 2 power mn minus 1, so you check it. So for all values of m and n, you will get this is a odd number. So this is an even number and it is odd number. Product of even and odd is equal to even number. Then how to check? Check here, we will use the trial and error method. Now you have to split this 112 into even into odd. Let us check is, first you take 2 into 112 means 56. 2 5s are 2 12s are right. So both are even numbers you are getting. Again 4 into 14. So 4 1s are 4. Can I take 2 into 28? Can I take 2 into 28? No. No, that is also not there. So again here 2 into 7, this is 2 will come 8 into 7. So here 2 into 28. So 2 2s are here. You can write it as a 4 into 2 into 7. 4 2s are 8. 8 into 2 14s are. So that is 18 into 14. 8 into 14. Now both are even numbers. Now this is also not possible. 8 into 2 into 7. 8 2s are 16 into 7. Can you write it as? Yes, I can write. We can write it. So 16 7s are 7 6 are 42. 7 1s are 7. 112. It is right. So therefore 2 power n value should be 16. Value should be 16. 2 to the power of m minus n minus 1 value should be 7. This should be even, that is 7. Very clear. Here very clear, your n value is equal to 4. N value is equal to 4. Now coming to m value, so this is equal to 2 power m minus 4 is equal to 8. This is 2q. Therefore m is equal to, so this is equal to 2q. So m minus 4 is equal to 3, therefore m is equal to 7. Understand? So n is equal to 4, m is equal to 7. M into n, we want m into n. M into n is equal to m. 4 7s are 28. So it is a very logical problem. The first thing up to here, any student can do. Any student can do. Up to here, this equation they will get. But after this, solving is a somewhat. Here you also, some general students, what they will know, they will start trying trial and error method. Trial and error method also. So here m is 2 power 4 minus 2 power 7 minus 2 power 4 will give 112. Like that, general students will do trial and error method. So this is also one sort of trial and error method. Okay, na? So I hope that you understand this solution. Let us go for next problem. Dear students, welcome to second problem. So this problem is appears to be very easy, but there is a small logic here. So if you understand this problem, so the next third problem is you can easily understand. So this is a very small problem. So look at the problem. There are 25 students in a class, right? Clear. There is a class in this. In that class, 25 students are there. Okay, 25 students are there. So 25. How many students are there? 25 students are there total. Okay, right. Every student reads 10 newspapers. Every student reads 10 newspapers. That means these students read 10 newspaper. 1, 2, 3, 4, 5 like this, 10 newspaper. He also reads 10 newspapers. He also read 10 newspapers. He also read 10 newspapers. Understand this? Altogether 25 students are there. Every student reads 10 newspapers. Okay, next don't read the second condition. Find the total number of newspapers means what? Total number of newspapers, how it will be, how many will get? Anybody can say that 25 into 10 without condition. If so forget about the second condition. The first condition is there are 25 students in a class as 25 students. Every student reads 10 newspapers. Every student reads 10 newspapers. So try to understand this. These are not disjoint sets. These are not disjoint sets. That means the student A and student B. That means the student reads 10 newspaper. Student B reads 10 newspapers. But they are not different. They are not different. That means there are some newspapers which are read by both. Which are read by both. Both students they read. Both. That means there. So here, for example, there are some newspapers. For example, Eenadu, Andhra Jyoti. Here also they read. So Hindu, Deccan Chronicle. This is also Hindu, Deccan Chronicle. There are some newspapers which were read by both the students, like that. That was given by. So actually, by speaking, total number of, without any condition, what the total number of newspapers are how many? 25 into 10, 250. The problem is over. But see here. Each newspaper is read by 5 students. Each newspaper is read by 5 students. That means if one newspaper is there, that is read by 5 students. Out of 25 students, each newspaper is read by 5 students. That means what? Total newspaper that you are counting how many times? 5 newspapers. Each newspaper is read by 5 students. In 5 students, you are counting again. Double count is there. So, in order to reduce that, what you have to do? Simply divide with 5. Simply divide with 5. What is the condition? Each newspaper is read by 5 students. That means you are counting 5, 5, 5, 5. Again, double time you are counting. So, in order to make reduce, you have to do what you have to do? You have to divide with 5. So this is your answer. So this is 25 into 10 by 5. So this is your answer. The first thing is without any condition. 25 into 10. Those many newspapers are there. But the intersection part is there. What is that intersection part? Each newspaper is read by 5 students. You are now, your extra counting is no. So how many you are counting? By 5. If you divide with 5, total number of problems will become. No? So using this knowledge, we are going to solve a very interesting problem. Let us see that problem. Okay, now? Dear students, welcome to third problem. So very important problem this is. So it was previously asked in some competitive examinations. The question is, suppose A1, A2, A3 so on A30 are 30 sets each with 5 elements, and B1, B2, B3 so on Bn are n sets each with 3 elements. Okay. The union of all 30 sets of A, that means A1 union, A2 union, A3 and so on 30 is same as B1 union, B2 union, B3 union so on Bn. And each element of S belongs to exactly 10 of AIs and 9 of BJs. Then find the number of elements of number of sets of B. Right. So to do this problem, just a previous problem, you try to understand this. Don't read all the complete problem. First read the first statement and last statement. Suppose A1, A2, A3 are 30 sets, each with 5 elements. Each with 5 elements. Therefore, total number of elements which belongs to all the A sets are how many? 30 into 5. Very clear. 30 into 5. There are 30 sets are there. In each set there are 5 elements are there. Each set 5 elements are there. But we will think that there are 3 5s or 150 elements are there. But the thing is, there are some elements which belongs to both A1, A2, A2, A3, A1, A3 and A5, A6. How many are there? 10 elements are there which are common elements are there. Understand? So to make to the perfect, what you have to do? You have to divide with 10, just like a previous problem. That is about A. Coming to B, how many sets are there of B type? N sets are there. Each with how many elements are there? 3 elements are there. That means total number of elements belongs to N is how much? 3 into N. But in that, there are 9 elements are there common to 9 of BJs belongs to this set S. That means what? 9 elements are common to all this, common to all the sets B1, B2, B3 so on B1. That's why for to make it equal, what have to do? We have to divide with the 9. Okay now. And one more thing is condition is given. That means the union of all the elements of A is equal to the number of elements in A is same as number of elements in the union of B. It is nothing but universal set. So that is meant these two are equal. That's all. So if you calculate this, the problem is over. So 3 1s are 3 3s are. So 5 1s are 5 2s are. 2 1s are 2 15s are. So 15 3s are 45. So n is equal to 45. So the number of elements, the number of sets of B type are 45. So very easy problem. This is the first thing is number of elements in A, but 10 of exactly 10 of AIs belongs to the common elements. That's why we divide with 10, like that also divided. So I hope that you understand this solution. So let us go for next problem. Dear students, welcome to fourth problem. The fourth problem is, see here clear, in a school every teacher teaches either maths or physics. Be careful about every teacher. That is very important. In a school, every teacher, whoever the teacher is there, they teaches either maths or physics. Remember that he says that either teaches maths or physics there, but you have to be careful about this statement that there are certain teachers who teaches both maths and physics. There are certain teachers who teaches both mathematics and physics. Be remember that. If 15 teaches maths and 24 teaches physics while 6 teaches both, then find the number of teachers. The number of teachers who teach physics only. So very easy. So number of teachers who teach mathematics are how many? 15. Number of teachers who teaches physics only how many? 24. And the number of teachers who teach both maths and physics is equal to how many? 6. He is asked to find out the number of teachers. So here, observe here, every teacher teaches. That means whoever teaches maths and physics, this is nothing but equal to universal set S or mu. Understand this? So there is no teacher who does not teach any subject. Every teacher teaches either maths or physics. So this is given by n of, he is asked the total number of students means n of A, that is n of A union B, that is M union physics P, that is n of M plus 24 minus 6. So 24 plus 24, so this is 39 minus 6. So 39 minus 6, this is 33. So if you draw the Venn diagram here, Venn diagram, so this is a physics and it is a maths, it is a physics, total number is 6, and here you will get here you will get 9 and here you will get some 18. Okay now. So the total number of teachers are 9 plus 6 plus 18. So that is equal to 33. And the second question is the number of teachers who teach physics only. Number of teachers who teach physics, how many? 18. So your answer is 33, 18. So the thing what you have to observe is every teacher teaches either maths or physics. So no teacher is ideal. Every teacher. So see the next problem. Starting question will be different. Okay, na? So let us see the next problem. Dear students, welcome to fifth problem. In a class, 60% passed physics examination and 58 passed in mathematics examination. That is, physics exam is passed by 60%, maths exam is passed by 58%. See here, try to understand here, it is not given that every student, So in the previous, every teacher teaches maths or physics, but here it is not given that every student passed in physics and maths examinations, but some. So he is considered only in maths and physics only. Some students are there. There are certain students are there who passed in both maths and physics, botany, zoology. Some students are there in the class, in the total school. Some students are there, but he is concentrating only on physics and maths. Okay, try to understand this. Now he is asked to find out at least what percentage of students of this class passed both their physics and maths exams. At least what percentage of students passed both maths and physics examination. Okay, so if you take that universal set as 100 students, some 100 students, we are considering 100 students only, 100 students. So n of u is equal to 100. So n of physics is equal to how many students passed? 60 students. N of maths, how many passed? 58 students. But try to understand here, in the school, n of P union M is greater than or equal to 100. Try to understand here, greater than or equal to 100. But in the total school, more than 100 students are there. In the 100 students, which we are considering these students. We are considering 100 students here. But in the school, total school is more than 100 students are there. Okay, now, right. So here probability of P, so n of P union M is equal to what? So this is a 60 plus 58 minus n of P intersection M is greater than or equal to 100. So if you calculate this, this is a n of P intersection M is less than or equal to 18%. If you calculate this, take this set and n of P intersection B is 18%. So that means he is asking at least what percentage of students. So that is 18% of students passed in both their physics and maths exam. Understand this? So try to understand here n of P union M is greater than or equal to 100. Okay, na? N of P union M is greater than or equal to, that means there are some students who passed in botany, zoology, all those things here, total. But here we are considering the 60 and 58 is regarding 100 students. Understand this. So I hope that you understand this solution. Let us go for next problem. So dear students, he is asking the number of elements in the smallest subset of X containing both A and B. That means here, this is a set A and a set B and it is a X. if you observe here, A union B is also a subset of X. So see here, so total it is a X set. In that X, A union B is also a subset of X. Is also containing both A and B. So if you observe here, if you take the set A, that up to that only it is A containing. If you can see the set B, that contains only B elements. Here A intersection B contains both A and B. But if you observe here, A union B is the set containing both A and B, and it is also a smallest subset. Okay now. So if you observe here, N of X contains 50 elements, N of A contains. So what is the set A? First I will write down set A is equal to multiples of 2. What are the multiples of 2? 2, 4, 6, 8, so on 50. That means N of A is equal to 25. What are the set B? B contains multiples of 7. That means 7, 14, 28, so on 49. So N of B contains 7. 7 sevens are 49. What about N of A intersection B? N of A intersection B is what? This is a 2 and a 7. LCM of 2 and 7 is 14. So this is here 14, 28, 32. So 14, 28, 32. So these are the, again 14, 42, sorry, 42. 14, 28, 32, 42. These are the three elements which belongs to both A and B. That means N of A intersection B is equal to 3. Therefore, so what is the smallest number of elements in smallest subsets of B? A means what? You have to find out N of A union B. So what is N of A union B? So N of A is equal to how much? Number of elements in A is 25. The number of elements in B is 7. The number of elements belongs to both A and B is 3. So if you calculate, so 25 plus 7 is 32, 32 minus 3 is 29. So 29 is your answer. Okay na? So very well. So the thing what you have to observe is, here A union B is also a subset of X which contains both A and B. Okay na? So I hope that you understand this solution. Dear students, welcome to 7th problem. A set contains 2n plus 1 elements, then the number of subsets of this set containing more than n elements is. Let your set be A, that means A contains 2n plus 1 elements. You want the number of subsets of this set containing more than n elements. More than n elements means what? You want the subset containing n plus 1 elements, the subset containing n plus 2 elements, the subsets containing n plus 3 elements, so on, the subsets containing 2n plus n elements. Understand? The number of subsets of this set containing more than n elements. That means more than n means what? N plus 1. So you want to find out the number of subsets containing n plus 1 elements. The number of subsets containing each set containing n plus 2 elements. For this, what you have to do? N plus 1, out of 2n plus 1 elements, you have to select n plus 1 elements. That means this is given by 2n plus 1 C n plus 1 plus number of subsets which containing the elements n plus 2. So on, last one is 2n C 2n plus 1. If you find out this value, the problem is over. Understand? So how to get this value is a very easy one. So see the expansion of, so this is a 1 plus x whole power 2n plus 1 expansion. So this is equal to 2n plus 1 C 0 plus 2n plus 1 C 1 into 1. Understand this. Again, what you will get? 1 to the power of 2n plus 1, that is, and x power 0. So this is a next one, 2n plus 1 C 2, this is equal to 1 square plus so on, last 2n plus 1 C. Again it will come here x. x square. So this is equal to x square will come here, x will come x square, so on 2n plus cn, 2n plus 1, x to the power of 2n plus 1 will come. So put x is equal to 1, what happens? So this is a 1 plus 1, 2 to the power of 2n plus 1 is equal to 2n plus 1 c0, 2n plus c1, 2n plus c2, so on. Here 2n plus 1 cn plus 2n plus cn plus 1, 2n plus 1 cn plus 2 plus so on, last one 2n plus 1 c, 2n plus 1, last one. So in a binomial theorem, you here 2n plus 1 is a odd number. Just one example I will see here. X plus y whole cube, that is x cube plus 3x square y plus 3x y square plus y cube. Observe the binomial coefficients here, 1, 3, 3, 1. Sum of the binomial coefficients of first two terms, that is 1 plus 3 is equal to how much? 4. Here 3 plus 1 is equal to 4. 1 plus 3 is 4, 3 plus 1 is 4. Here also 2n plus 1 is a odd number. 2n plus 1 is a odd number. The sum of the binomial coefficients up to n plus 1. Up to n plus 1. So that means 2n plus 1 0, 2n plus 1, 2n plus 2, so on, 2n plus. Up to 2n. Up to 2n. This is same as 2n plus c, n plus 1. 2n plus c up to here. Remaining all. N plus 1, n plus 2, n plus 3, so on, up to that. They are same as. That means 2 times, that is equal to, here 1 plus 1, 2 to the power of 2n plus 1. So that means 2 to the power of 2n plus 1 is equal to 2 times this binomial coefficient, that is 2n plus 1c, n plus 1, 2n plus 1, c, n plus 2, so on, last one 2nc plus 1 plus 1. So if you come to this side, 2 power 2n plus 1 by 2, so a power m by a power n, so 2 will get cancelled, you will get 2 to the power of 2n number of subsets. So this is equal to 2 to the power of 2n. Option D is the right answer. So I am saying total number of elements are 2n plus 1. So we want the number of subsets which containing more than n elements, means n plus 1, n plus so on to n plus 1. So if you want to do this, so see the binomial expansion of 1 plus x whole power 2n plus 1. So here also 1x, x square, so on, x power 2n plus 1. Put x is equal to 1. So this is equal to 2 power 2n plus 1. So if you observe these, this is a 2n plus 1 is a odd number. So you will get an even number of terms. In this even number of terms, the sum of the binomial coefficients of the first half is same as sum of the binomial coefficients of the second half. We want the second half from n plus 1 to 2n plus 1. So from 0 to n plus 1, n plus 1, n plus 1, 2n plus 1. So here first two, here 2n plus 2 terms will come, 2n plus 2. So half is n plus 1, second half is n plus 1. Understand? So the sum of the binomial coefficients of the first half is same as the sum of the binomial coefficients of the second half. That is, we want the second half, that is 2 times. So divide with 2 power n plus 1 by 2. So this is 2 power n. Okay. So dear students, I hope that you enjoyed today's class, and in the tomorrow's class with some more problems I will stand before you. Okay. So until then, all the best.